Good morning, ladies and gentlemen. So it is time for Christmas. Woo, I'm excited about that. So we've got our board decorated for Christmas now. All right, we're going to get started today with Algebra 1/2, Lesson 40. Algebra 1/2, Lesson 40. This is about your addition and subtraction rule with equations. So in our last algebra lesson, we looked at the beginning of equations and how you solve them. Well, now we're going to start jumping into ones that are, I wouldn't say difficult, not yet, but that add extra steps to what you have to do. The last ones you could all do in your head. These ones not necessarily. You need to do a little work with them. But first, let's look at these equations that I have in blue. So I have x equals 6, x plus 3 equals 9, x minus 3 equals 3, 3x equals 18, and x over 3 equals 2. All of these are very different equations with how they are being worked and how you solve them. However, they all have the same solution. X equals 6. The very first one is easy. It tells us that without having to do any work. X equals 6. But if we put 6 in place of x in every equation, it would be a true equation. So 6 in place of x here, 6 equals 6. Yep. 6 plus 3, is that 9? Yes, it is. 6 minus 3 is 3, so 3 equals 3. 6 times 3 is 18, so 18 equals 18. 6 divided by 3 is 2, 2 equals 2. So it would all be a true equation with 6 as your solution. So we would call these equivalent equations. Equivalent equations, because their answer is all the same number that would solve it. So that's what an equivalent equation is. But how do I solve equations like this? Equations that I can't necessarily do in my head. Well, we have some rules for that. The first rule is the addition-subtraction rule. And this rule is very simple. This rule states that whatever I do to one side of my equation, I have to do the same operation to the other side. So if I do it on one side of the equal sign, I have to do the very same thing on the other side. Let me demonstrate. X minus 3 equals 7. Well, I know that to get x by itself is my goal. And to get x by itself, I have to do the opposite of whatever I'm doing to x. Right now I'm subtracting 3 from x. What's the opposite of subtracting 3? Adding 3, right. So I'm going to add 3 to x. But according to my rule, whatever I do to one side, I have to also do to the other. So I have to add 3 to 7 as well. And so that gives me, cancels out my 3 here because a negative 3 and a positive 3 equals what? 0, right? So x minus 0, so that's just x. So that cancels out. I have x by itself now. 7 plus 3 is 10. Very good. So x equals 10. Now I need to put 10 in place of x so I can check it. 10 minus 3 equals 7, and yes, this step is necessary, you have to do it. 10 minus 3 is 7, 7 equals 7, my answer checks. So x equals 10 is my answer. All right, let's try another one. X plus 3/4 equals 9/11. Okay, what am I doing to x? I'm adding 3/4. So what would be the opposite of that? To subtract 3/4. So I'm going to subtract 3/4, and if I subtract something from one side, I have to subtract it from the other. So that gets rid of x over here, or excuse me, gets rid of 3/4 over here. I'm just left with x. Over here, I can't subtract yet because I don't have the same denominator. So first I have to change my fractions so they have a common denominator. What's the least common denominator of 4 and 11? 44, very good. So I'm just going to really quickly change these fractions. 11 times 4 equals 44, so 9 times 4 equals 36. 4 times 11 equals 44, so 3 times 11 is 33. Now subtract 36 minus 33 is 3. My denominator stays the same, 44. So x equals 3/44. I need to put 3/44 in place of x plus 3/4 equals 9/11. So I have to change my 3/4 to 33/44. in order to add it together. That's a really easy conversion because I already made it up here. 3 plus 33 is 36 over 44, which I already know reduces to what? 9 over 11. So that equals 9 over 11. So 9 over 11 is equal to 9 over 11. My problem checks. So x equals 3 over 44. All right, let's try one more. X minus 3/5 equals 2/10. What am I doing to x right now? I'm subtracting 3/5, that's right. I'm going to go ahead and erase some of this so that my board's not quite as crowded and you can see it a little better. Okay, so if I'm subtracting 3/5, I have to add 3/5. And according to my rule, whatever I do to one side, I have to also do to the other. But in order to add these, they have to have a common denominator. My 3/5 over here cancels out and it's just x. So x equals, well, the least common multiple of 5 and 10 is 10, so that's easy. This one stays the same. 5 times 2 equals 10, so 3 times 2 equals 6. Now I need to add that together. 2 plus 6 is 8, so it's 8/10. I can't leave it like that because 8/10 can be reduced. 8 divided by 2 is 4, 10 divided by 2 is 5. So x equals 4/5. All I need to do now, excuse me, is put 4/5 in place of x. Four-fifths minus 3/5 is 1/5. 1/5 equals 2/10. Now you might be saying, Miss Ashley, that's not the same. Well, think about it. 2/10, can that be reduced? Yes, it can. What does it reduce to? 1/5. So 1/5 equals 1/5. So it is the same. 4/5 is the correct answer. All right? That's all you got to do, so pause now and do your practice on page 114. Okay, you should be back now with your answers. Letter A equals 2. Letter B, x equals 6. That was a really easy one. Letter C, x equals 1/4. And letter D, x equals, ready? 15 over 12. This will be 15 over 12. If you change that to a mixed number, that is acceptable, but it's better to go ahead and leave it as an improper fraction. 15 over 12, because you have to check it being an improper fraction anyway. Okay? So save yourself a little time there. That's it for today. Have a wonderful day. Merry Christmas.